Science skills!
Yo.
Unit conversions and algebra, essentially rearranging formulas. Ladies and gentlemen, still just your fundamental skills to help you through physics or really just...
And I don't know if any of you remember
science
this little meme we got going on here, but this was around the time when McLeod was born in the 70s, early 70s when this started coming out. This is Star Wars.
To my credit, I was born when the last one was released.
Old! Conversions! When we take measurements, we always take the unit, whether it be centimeters, meters, liters, whatever the case may be, depending on the instrument used to make those measurements. Okay, we use a conversion factor to convert measurements from one unit to another, which we sometimes have to do in calculations.
And we always want to see units. Don't tell us that you have 4. You have 4 what? 4 hand grenades, 4 fuzzy kittens. We need a unit. What did you actually measure?
So we're going to take a walk down memory lane and go back to moles and think about what we did with those conversion factors with this next example of sodium chloride. Come on, McLeod. There we go. Okay.
Sorry, my old fingers struggle to push the screen.
Obviously, we know sodium chloride is NaCl. Okay. If we take a look and we want to convert 5.0 grams of NaCl to moles like we did before, we know the conversion factor for NaCl, the molar mass, is 58.44 grams per 1 mole.
That's a 58, not a 68.
Yeah, all right. Here we go. There we go. Okay, so we use that conversion factor just like we had before. Okay, we put grams on the bottom, mole on top.
Why did you put grams on the bottom?
Well, if we're doing unit analysis, we want to cancel out the grams.
Perfect.
Okay, now we have the 58.44, and it's on the bottom of that conversion factor, so we are dividing. This is the conversion factor we are talking about. So we get an answer of
0.0855578. A lot of 5s just for Rainier.
And again, we take a look at significant digits. We have 2 here. Okay, we have 4 here. It's going to count out at 2. We round, so our answer here would be 0.086 mole.
But Mr. Rainier, how come you didn't include that little 1 in the conversion factor?
Those are non-measured values like we talked about before, so they don't play into significant digits like Mr. McLeod said in the last video.
58.44 grams is the mass of exactly 1 mole. It's not a measured 1 mole, it's exact. It does not count for significant digits. So, where do we find conversions within metric system? Ladies and gentlemen, there's lots of different diagrams, there's lots of different ways to show this. This is a stepwise. It works really nice because it starts to show you numbers that get bigger, it shows you numbers that get smaller, it shows you scientific notation on the right, it shows you the names of the prefixes that will go before your units on the left, but at the same time it can also be a very confusing diagram to look at. So we normally pick on those ones with the stars. Those ones with the stars are the very common conversions that we look at because they happen to move by factors of 1,000.
So if we're taking a look at this in terms of how we're jumping through the list, and we can look at the last slide for that as well. Okay, if we're taking a look at our base unit is usually found right here in between deca and deci. Okay, so that our base unit is things like grams, joules, liters, all that kind of stuff. So if we're climbing up the list, we're climbing by factors of 10. Okay, so if we take a look and we jump up this factor, we'd be going, if we went from our base unit of liters here to kiloliters, we'd be going 3 jumps. 1, 2, 3. So again, 10 times 10 times 10 is a factor of 1,000. So if we take a look at the metric staircase on the next one, it's the exact same thing, just a different look. Okay, we have going to kilo at the top and our base unit right here. As we climb the stairs, we're dividing. As we go down the stairs, we're multiplying.
Hopefully this makes sense. If we go to a bigger unit, you should have fewer of them representing the exact same number. Same, as you go to a smaller unit, you will end up with significantly more things. So, let's try a couple. The very first one, we're going to convert 10 centimeters to millimeters. Mr. Rainier is going to take this first one, I'll take the second one. You'll see that we probably do it just about the same, but with minor little differences. We don't care how you do yours as long as you can show us, and as long as you actually convert them properly.
So now, with this first example, I'm starting with centimeters. So I'm going to find centimeters on my list, right here. and we're trying to go to milliliters. So this is where we want to be. X marks the spot. Okay, so now we're going to start with 10 centimeters, and we're going to try to figure out our conversion factor. We are going down the list, so we are going to be multiplying. Okay, but we know that as a result of that, we know it's a factor of 10. So there are 10 millimeters per 1 centimeter. Okay, so we're going to use that conversion factor in order to cancel out our centimeters and get millimeters, like we have here. So, as a result, okay, 10 times 10 is what?
100.
And then obviously our centimeters cancel out, so we have our new unit of millimeters.
So, slightly different twist on the exact same kind of idea. Just because, ladies and gentlemen, this is a skill. As long as you can do it, we're happy. We have 9 milliliters becoming liters. Same idea, we're going to start with what we know. We know that we have 9 milliliters. From unit analysis, I don't want milliliters. I'm going to put milliliters on the bottom. What I do want is I want liters, so I'm going to put liters on top. Now, I just need to know the conversion between liters and milliliters. So the way that I often do some of my conversions is I start with the unit that is bigger. If I look at milliliters and liters, if I scroll up to that table again for one moment, I can see that liters should be around 10 to the 0. Milliliters is down here. Milli is smaller. So I'm going to start with a 1 on the number that is bigger. And the milli, it said that it was 10 to the 3 up here. 10 to the 3 is 1,000, so there must be 1,000 milliliters in 1 liter. So in this case, we do a division, and we end up with 0.009 liters, still with one significant digit. The last one, pretty much the same idea, only this time we're going from a big unit to a small unit. 1.76 kilograms times, if we don't want kilograms anymore, they could go on the bottom. Grams could go on the top.
And again, we're going to take a look at the list at the very top, and to figure out how many are there, obviously we know we're starting at kilograms,
which is 10 to the 3 up here. And we're trying to go to the
base unit.
So that is
grams.
10 to the 0 for the base unit. So, for McLeod's method, I would put a 1 on the kilogram, it's the bigger unit. And then a 10 to the 3 means that there are 1,000 grams in a kilogram. This time we're doing multiplication. 1760 grams on the calculator. With 3 significant digits, this becomes 1.76 times 10 to the 3 grams. We don't get to keep that last 0. And you'll notice this 10 to the 3 grams is actually exactly how many grams were in a kilogram.
Of course, there's one unit these tools do not work for, and that's time. And we're going to see that a lot in physics. Instead of climbing by factors of 10 like we saw in the previous table, time deals with weird factors. We know, for example, that there are 60 seconds in 1 minute and 60 minutes in an hour. Well, at least we hope you know this at this point.
If not, we got some trouble.
So if we take a look at these conversions, we have the conversion factors already for us, so we are going to start with 2.45 hours, and we're going to try to convert to minutes. Now, how many minutes are in an hour? 60. So, again, we're going to start with balancing out the units. We know there's a relationship between hours and minutes. I want to get rid of hours, I put it on the bottom, okay? And so the bigger unit gets the 1. The 60 will go with the minutes because we know that there are 60 minutes per 1 hour. And we have the units we want and we're ready to go. 2.45 times 60 gives us 147 minutes. Again, we have 3 significant digits and 2 here.
No, we don't have a 2. This is a defined value. Because there are exactly 60 minutes in 1 hour, the 60 minutes in 1 hour actually doesn't give us any signigs at all.
So now we're just rolling with the 3. Okay, so we have the perfect number of significant digits in the answer that we got, and we're ready to put a little box around this, and we're good to go to move to the next question. Go, McLeod, go!
16:45 seconds become hours. Now, ladies and gentlemen, there's 2 ways that this one can happen. We'll lay it out as 2 steps, and then we'll show it as a 1 step where it's essentially the same thing. We start with 16.45 seconds times... Mr. Rainer, what if I don't know how many seconds are in an hour? I could still get rid of seconds. I don't want seconds anymore, but I could turn them into minutes. Now, at this point, if I did a calculation, I'm going to have minutes, and that would be great, but I don't want minutes, I want hours. So I'm going to put on another conversion.
Dun dun dun!
This time I'm getting rid of those minutes I just created, and I'm trying to turn them into hours. Same idea as before. Minutes are seconds, minutes are bigger. Hours and minutes, hours are bigger. There were 60 seconds for 1 minute. There were 60 minutes in 1 hour. We can smash this into our calculator. And we get 0.4569 hours.
And that's a 5, not a 6.
Yeah, this one here was the 5. The next one was the 6.
Yay!
All right. Now, ladies and gentlemen, in physics, students often start seeing that this actually can be memorized as 1,645 seconds times 3,600 seconds in 1 hour. If you end up memorizing this, good for you. If you don't memorize this, that's fine. Stick to the method in the big box where you do it as 2 separate steps. You will be just fine.
So for the last example, we're going to take add another conversion factor into there. We have 0.54 days, and we need to convert that to minutes. Okay, so we are going to know, we're going to put days in the bottom because we don't want that anymore. And obviously we know how many hours are in a day, which are 24. Okay, and if we're trying to go from hours to minutes, again, we're going to set up another ratio because that's not what we want. Okay, and we're going to put hours in the bottom, minutes on top, okay, and we know that there are 60 minutes in an hour. So we're going 0.54 times 24 times 60 to give us an answer of 777.6 minutes. Okay, obviously we have 2 significant digits in the question, so we're looking at here. We're going to go into scientific notation and see 7.8 times 10 to the 2 minute.
Done. Nice and easy. Guys, practice it. The more you practice this, the easier it gets, the faster it gets, and the less likely you are to make a mistake. Rolling right along. We are going to have to also rearrange formulas. Apparently we cannot unselect this box under rules of algebra. So, there are a couple of rules. Ladies and gentlemen, normally when we are doing math, we can add, subtract, multiply, and divide anything as long as you do it to both sides of an equal sign. Hopefully you already know this from math. Anything you do to the left is the same thing that you do to the right. As long as you do it to both sides, it's still equal.
Rule number 2. To move or cancel out a quantity or variable on one side of the equation, perform the opposite operation on both sides of the equation. For example, if you had g minus 1 equals w and wanted to isolate g, okay, we would add 1 to the other side. Okay, so again, a helpful hint here is the fact that we use BEDMAS to solve math problems like we did before. But when it's opposite when rearranging.
So if we're doing the opposite for rearranging, it's not BEDMAS, it's SEMDEB. Let's try an example. Here we have v equals pi r squared h over 3. We want to rearrange this. It doesn't really show it very clearly, but we're going to try to rearrange it to get r all by itself. So, we started with our formula exactly the way it looks. It's v equals pi r squared h over 3. At this point, we would look at the r and say the r is being multiplied by pi, it's being multiplied by h, it's being divided by 3. We want to do all these things the opposite. Now, how do we do this the opposite? Well, ladies and gentlemen, from our unit conversion, or from our unit conversions in moles, we like thinking about things as being tops and bottoms. So at the moment, the r is on top. We like r being on top. We want him to be all by himself so we can say r equals. The only catch is he has all this riffraff hanging around with him. So let's get rid of the riffraff. If there's a 3 on the bottom, how do I get rid of a 3 on the bottom? I would put a 3 on the top. Now, this is a divide by 3, so putting a 3 on top says multiply by 3. That is the opposite operation. But if I do it to one side, I better do it to the other. R is still not by himself. He's got an h there. We want to get rid of this riffraff, so we put an h on the bottom. They cancel out, but I do it to the other side, and I do the same thing to the pi. Now, at the moment, we have a formula that I'm going to rewrite to make it neater. R squared is 3v over pi h. Now, this is where we have to start looking at really doing the opposite. What is the exact opposite of squaring something?
Square root!
It is the square root. On a calculator, it's the same button, but with a second function. So if I took the square root of both sides, I would be getting rid of that squared. R is equal to the square root of 3v over pi h.
Okay, so I'm going to do things a little bit slightly different than McLeod did, but again, either way works. We want to see that you guys can get this done. So I'm obviously looking to isolate h in this question. So again, we're going to do the opposite of BEDMAS to do adding and subtracting first. So I'm going to leave this term alone and take care of this adding first. The opposite of adding would be
Subtracting!
So I'm going to subtract 2 pi r squared from both sides. So my new equation is s minus 2 pi r squared, okay, is equal to 2 pi r h. Okay, now we know that the 2 is multiplied by the pi, r, and h. So we have nothing but multiplication happening here. So the opposite of multiplication is
division!
Yay! So we're going to go ahead and divide. So I want to leave h alone. So I'm going to divide 2 pi r on both sides. Okay, so again, these cancel each other out. We're left with h. And we are going to divide 2 pi r on that side. And now we're done. We have h by itself, and we're going to rewrite it in a nice pretty form. S minus 2 pi r squared divided by 2 pi r. And we're done.
Now, guys, we don't necessarily want you to become absolute pros at rearranging equations, but we want you to try some of these things so that when we start into physics and we start dealing with the formulas of physics, you're aware of the general idea of rearranging, and then we'll do that to every single physics formula that we use.
Yes!
Do we need to do this one? Do we want to do this one?
Let's move on.
Ask us in class if you want to see what this one looks like.
Until next time, Science 10, stay classy.